Assalamu alaikum students. In the last lecture, we discussed about the shortcomings of the traditional software specification and software design methods, which actually bring the need of the use of formal methods. And we highlighted that formal method also used to represent the software specification and software architecture. Students, we have already discussed that formal methods use mathematical notations to describe the software specification as well as software architecture in a precise way. In this lecture, we will discuss the following points: why to use formal methods, and at what stage of software development we will apply formal methods, and how can we apply formal methods, and how can we get the abstract representation of software using formal methods. It has been discussed in the last lecture that conventionally we use diagrams to represent software design, as well as we use natural language for the software specification. However, such methods have shortcomings, which include these methods are unstructured and different person can get different meaning from such kind of specifications, and these methods don't have any standard notations or standard syntax, and it is impossible to prove that the method used for the specification and the specification is correct or not, and it is difficult to establish a precise mapping rule to transform a specification into program or in the form of an algorithm. In order to overcome the shortcomings of traditional software specification methods, we use formal methods which describe that what a software must do without running any program or code, or in fact without writing any code. This ability to model behavior distinguishes the formal methods from diagrams that can only model program structure. Formal methods can help you to create software in such a way that you can understand the behavior before to run a code. This means that we can discover many errors without having to run any testing on the developed code. Analysis is a process to understand the software architecture as well as software behavior without running any program, and it actually involves reading, discussing, and trying to understand programs without testing. Formal methods have ability for the analysis of software, and formal methods make it possible to derive designs and code from a specification and to check whether code and design correctly implement a specification or not. Therefore, formal method ensures that whether our specification is a true reflection of our requirements, and then it also helps us whether our design is a true reflection of our specification, and it would also help us that whether our code is a true reflection of our design or not. Students, formal methods are descriptive representation of software, and formal methods describe that what a software must do without giving any detail of its construction. Formal methods basically provide validation that our formal specification are actually according to the requirements of software, and it also provides the verification that whether our design is according to our formal specification, and it also provides the verification that whether our code is according to our design or whether our code is a true reflection of design as well as specification given by the customer. Formal methods use mathematical notations. Therefore, formal methods provide analysis for the software design without running any code, or in fact without writing any code. And analysis has advantages on testing for many purposes. Testing cannot take place until some implementation is available. Therefore, correcting errors uncovered by testing could involve retracing many steps and undoing work previously done. Moreover, testing can only help to uncover errors. It cannot guarantee the absence of errors. And testing can only be performed when implementation is done. On the other hand, formal methods use mathematical notation which can provide the correctness of specification, and the specification is error free whenever we perform the formal analysis. Students, formal methods provide the descriptive representation of software. Therefore, we can use formal methods at the specification or design phase, and we can apply formal methods in the phases of the software development which come before coding, and formal methods involve writing another formal description of the program which actually provide the program analysis, and it helps us to show that that program is a true reflection of our specification. Formal methods use mathematical notation to describe the specification in a precise and concrete way, and we use formal methods to provide the model of a software and to provide the design of a software and to provide the verification that our design or specification is correct or not. A model provides us a simplified as well as abstract representation of a system, and we can use formal methods to model the behavior of a software or behavior of the program before we code it, and we use formal methods to model the state of a system, which actually the abstract representation of a software, and such state of a system contain different variables of different abstract data types such as sets, and then the behavior of different operations is then specified directly with respect to this state of the software. Design means organizing the internal structure of a software or of a program, and we use diagrams annotated with text such as block diagram or data flow diagram to represent the design of a software. Formal methods can be used at the design phase because it can model behavior, and formal methods provide us the descriptive representation of software, and design phase actually comes before coding. Therefore, formal methods can be used at this stage. We can use formal methods to express precise description of components and which component of the system are needed to perform any behavior. It can be modeled through formal methods. Verification means showing that whether our code is a true reflection of design as well as specification of a software. Formal verification is performed by theorem proving or by generating state space, which is known as model checking. Theorem proving is not related to executing the program, but proof is based on the specification and the program text. A proof system is a means of guaranteeing the correctness of a statement and relies upon mathematical logic. Students using formal methods is directly concerned with the formal specification, mean to say that the use of formal methods for the specification of a software, and then theorem proving technique to show the correctness of the formal specification, or using model checking technique for the correctness of specification. And formal methods is directly concerned with the abstraction of a software. Software design is directly concerned with the structural aspect of a software, and software design is also directly concerned to describe the behavior aspect of a software. And finding the best structure usually depends on understanding the behavior of a software. We already discussed that a software design is directly concerned with the structural aspect as well as behavioral aspect of a software, and structure of a software is related to the static aspect of a software, and state of a system or state of a software actually represent the static aspect of a software. We use invariant relationship whenever a state changes by applying any operation, and we need to observe that the invariant relationship is maintained when system moves from one state to another state. Students, operations or functionalities in a software describe the dynamic aspect of a system, and finding the best structure of a software usually depends on understanding the behavior and operations of a software are applied on a state of a system, and the relationship between the input states and output states of operations actually represent the dynamic aspect of a system. Students, conventionally we use diagrams to represent the structural as well as behavioral aspect of a software. As you can see that there are some diagrams which actually represent the structural aspect of a software, which include class diagram, package diagram, object diagram, component diagram, composite structure diagram, and deployment diagram. Similarly, some diagrams describe the behavioral aspect of a software, which include activity diagram, sequence diagram, use case diagram, state diagram, communication diagram, interaction overview diagram, and timing diagram. So, in order to get the abstract model from these diagrams, we actually divide the diagrams into two classes. Students, the diagrams representing the structural aspect of a software are actually represent the passive components of a software, and such passive components can be represented as a state of a system. Similarly, the diagrams representing the behavioral aspect of a software are actually active components of a system, which include operations or events, and such active components or operations can be represented as transitions, and by combining the states and transitions we can represent software into a formal model. Students, we have original specification of software in hand, and we convert it into a formal model, and then by using the formal model and the original requirements, we can apply model checking technique, which actually generate all possible states about the software in, and if all the generated states are according to the original specification, then our formal model is proved to be correct. If some states are forbidden or unwanted and not according to our original specification, then our specification has and our formal model has some error, and the forbidden states work as a counterexample. Students, in this lecture, we discussed that why we use formal methods. Then we gave comparison of formal methods and testing. Thereafter, we elaborate that how to use formal methods, which include formal modeling, formal design, and performing formal verification through theorem proving or model checking. And at the end of this lecture, we discuss that how can we get an abstract, formal or mathematical model of a software. Students, the contents of this lecture are taken from the chapter number 1 of the book Formal Software Development from VDM to Java, and chapter number 1 of the book Software Development with Z. So you must read both the chapters of the books, and that's all for today's lecture. Allah Hafiz.